Hello, my name is Frank. I'm a passionate Rhapsody user, trainer and coach, and love to share my experience to help you to become more effective. Today we are talking about how Rhapsody implements object-oriented principles in a procedural language in C. Rhapsody is a powerful code generator that directly converts UML models into executable C code. But how does Rhapsody manage to implement object-oriented concepts such as an object lifecycle, or encapsulation, or abstraction, modularity in a procedural language like C? In this video, we will take a look at the most important principles, and you will understand how Rhapsody makes it possible to generate object-oriented code in C. Let's get started. When creating a structural concept in Rhapsody, you have three options: class, singleton, or file. A class, the classical construct of object-oriented programming, serves as a blueprint for object. It allows the dynamic creation and destruction of multiple instances at runtime. If I know that I will only have one object of a class at runtime, I can also use the concept of a singleton. This concept is very memory efficient and ideal for hardware interfaces, configuration objects, database connections that only require a single instance. Perfect for the representation of existing C code is the concept of a file, which encapsulates a collection of global variables and functions without requiring direct object instantiation. Let's take a look at the individual concepts in detail, starting with a class. When I create a class and look at the code, you notice that Rhapsody generates two files: a header file, .h, which contains the declaration for the structure and the public operations, and an implementation file, .c, which contains the definitions of the operations and private implementation details. For a class, Rhapsody generates a typedef structure car as car. I create a new type car, which is actually struct car. This allows me to use car instead of struct car, which makes the code much more readable. Since structures cannot be empty in C programming languages, Rhapsody generates a dummy element in form of a macro. This ensures that a class-like structure without attributes can also be generated. When I add an attribute, this macro disappears. Next come the init and cleanup operation, which in object-oriented programming corresponds to the constructor and destructor, with which objects can be instantiated and cleaned up. This is followed by the create and destroy operations. Create allocates memory and creates the object. Destroy destroys the object and releases the occupied memory. In C++, this corresponds to the new and delete operators. Just as new calls the constructor in C++, in Rhapsody in C, the create operation calls init to initialize the object. With the create, init, destroy and cleanup operations, the object-oriented lifecycle's behavior can be mapped in a controlled manner in C. How does Rhapsody behave when I add an operation to the class? If I add a new operation, for example reset speed, this operation is declared in the header and is therefore public. To make it clear to which class an operation belongs to and avoid naming conflicts with global public operations, Rhapsody always adds the name of a class as a prefix. This ensures that each operation remains unique even if several classes contain operations with the same name. Since we can create multiple objects from a class, each operation must know on which instance it's being applied to. In object-oriented languages such as C++ or Java, the keyword this always references the current instance of a class. Since C has no classes, Rhapsody has to provide an alternative solution. Therefore, the me pointer is explicitly passed as a parameter to each operation. Me points to the called object. Without me, the operation would not know which instance of car to refer to. With me, I can directly access the attributes of the called object. The reset speed operation is currently public and follows the naming convention class name plus operation name. It is declared in the header and is globally visible. If the operation is set to private, the code disappears from the header and is only defined in the C file. The static modifier is used, so the operation can only be called within this file. If I only need one instance of a class, a singleton is the preferred concept. To do this, I select an object in the drawing toolbar and name it, for example, RTX, and then set the stereotype to Singleton. As you can see, a singleton generates much leaner code. Since no further instances are created, the mechanisms for new and delete are no longer necessary. All the other conventions remain the same. In the same way, since a structure cannot be empty, a dummy macro is generated that disappears when I add an attribute. Same for public operations. When I add an operation, we have the name of the class and the name of the operation. But since we only have one instance, the pointer me has disappeared. Instead, the attributes can be accessed directly via the dot operator. The data structure of the RTX singleton is defined via a structure with a postfix _t. This makes it clear that this is a type and not a variable. So struct RTX _t is the type of the structure. The actual declaration and definition of the singleton instance take place in the package code. In the header, the declaration is made with extern struct RTX _t, RTX. This allows other modules to access the singleton without creating their own instance. The definition is made in the C file. Memory is reserved for RTX and the only instance of the singleton is created. With a clean separation of declaration and definition, the structure remains visible in the header while the memory allocation is only made in the C file. This is in line with the best practice for efficient and modular code architecture in C. Unlike a class, a file does not directly support object orientation, but is a structural element used to map existing functions and variables. The file concept in IBM Rhapsody is ideal for organizing and visualizing existing C code in the UML model. When I create a new file, the code is initially empty. This is just a graphical representation of a .h or a .c file in the model. It is used to map a collection of functions and variables within the model. Otherwise, it familiar mechanisms. So I can add an attribute. No, in the case of file, it is called a variable. And an operation. In the case of a file, it's called a function. And I can implement the function and change the visibility in the same way. But as we can see, these are quite ordinary variables and functions of a file, which are visualized graphically as a class with a stereotype file. When I change the visibility from public to private, it changes accordingly to the conventions mentioned. So in summary, with a file concept, C code can be visually structured without having to convert it into an object-oriented class. And that's the end of our video. We saw how Rhapsody implements object-oriented principles in C, from classes with a clearly defined lifecycle to the singleton pattern and the visualization of existing C files. Do you have any questions or experiences with Rhapsody? Let me know in the comments. If you are interested in training, feel free to contact me at info@rhapsody.guru. Don't forget to like the video and subscribe to the channel so you don't miss any of these tutorials. Thank you for watching. See you next time. Goodbye.